Okay, for this integral, what I'm going to do, you don't need to do for the beginning. Honestly, you can just do this straight up. I'm going to rewrite it anyway because I really don't want to look at it this way. So I'm going to write it as u equals 4 minus 6x. du is equal to negative 6 dx. Okay, and like I said, this is perfectly fine to do, and you don't need to do it really, but I want to do it anyway because I just want to look differently for the sake of my mind. So we go from 0 to negative infinity. We're just going to put 0 into this. That's 4. And negative infinity into this. 4 minus negative 6 times negative infinity. That's infinity. Okay. So new integral is going to look like this. 4 to infinity. 1 over u, and dx is negative 6. My bad. Dx is equal to du divided by negative 6. Du over negative 6. And now I could just do this. But note, what do we note here? Okay, this integral goes from infinity to 4. So it doesn't really make sense, right? And yeah, that's true. Doesn't actually really make sense in this case. So let's realize that we actually should probably flip this as infinity 4, and put a negative 1 out here. Negative 1, right? So we have 1 over u, du, negative 6. Negative 6 times negative 1, that's positive. Okay, so I'm going to rewrite it again. But first, to make this a little bit more clerical, I'm going to write this as the limit as t approaches infinity, t 4, 1 over u, 1 second. I'm going to write this as 1, 6, 1 over u, du, t, and 4. Okay, so all I did is just change the notation here, and yes, you should probably do this, right? So you can see that. And the reason why I write the limit as t goes to infinity, because this is an improper integral. How do I know? It's not just the infinity sign, guys. That's not what tells you it's just improper. I mean, that is a big hint, obviously. But think about this again as a graph. 1 over u, right? I know that graph, like whatever that graph looks like, I always forget what my graphs look like. But let's just say it went like this, right? For the sake of it. Actually, it's going to be more like the opposite. 1 over u, right? This graph, we know as it goes towards infinity, something's going to happen. Like, what's 1 divided by infinity? 0, right? Okay. That's why you should have this little bit of a intuition on how the graph, right, this f of x actually looks, right? I don't, but you should. Okay. Now let's do this. This is going to be equal to 1, 6. And then I'm going to write the limit. Never mind. I'm going to write it like this. 1, 6 ln of u to u. Not ln of u to u, ln of u, and this is being evaluated as t goes to infinity and at 4. In other words, you can rewrite this as 1, 6 limit as, this says t goes to infinity, right? Okay, so I'm going to write this as t goes to infinity, and then it is kind of abusive notation here, as t. And note that I should write right here. No, that's fine. I mean, I think only some textbooks do this notation right here. Minus ln of 4. Okay, so this is it. And what do you think? Natural log of infinity. I think natural log goes like this. Right? That's the graph of the natural log. I kind of know that one a lot more familiar. This is the ln graph. ln graph. Okay. So ln graph, natural log of infinity is infinity, so we get 1, 6 infinity minus ln of 4. What is that? That's infinity divided by 6, which is infinity. Integral diverges, right? It diverges to infinity, right? There we go. Now we know, and you can see that this is divergent. divergent. And I'm going to say towards infinity, right? And I'm going to explain a little bit what this means here graphically with this graph right here. So we start from 4, and we go to infinity for 1 over u du. I mean, this graph right here. 4. Let's just say infinity, right? This is an infinite amount of area, so we get a divergent.